Alright guys, so we're going to get started with questions 18 through 22 today. So, flip to passage 4. Alrighty. 18. According to figure 1, at what temperature will AU begin to boil? So, AU, that's gold by the way. AU, figure 1, and we want it to, excuse me, we want it to boil. So, when the melting point is lower than eutectic phase diagram illustrates for the AUSI system 0%, blah, blah, blah. Okay, so we're going to go here. This is where it melts. That's not what we want. We want when it boils. So this is liquid plus AU, and this is liquid plus silicon, and this is liquid. So it's not going to be at any of these things because we want it to be above here. So this doesn't say, none of this phase diagram. Boiling is when what happens? So boiling is when it goes from a liquid to a gas. But this says liquid, 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 melting, melting, eutectic. And the eutectic point is when all of those meet, when the melting point of an alloy is lower than the melting point of its metal component. So that's the eutectic point of the AU and Si alloy. But all of those say melting points. None of these say gas. So gas is not on the figure. So the answer is J. All right, 19. Based on a figure 1, so we're going to go again to figure 1. An alloy that is atomically 50% silicon and 50% AU will be in what temperature, or what state? At a temperature of 600 degrees. So 50% silicon. That's what we're going to bring it up to. That was not a straight line. I apologize for that. But we are in 50% and at a temperature of 600. So it says liquid plus Si. So that's going to be liquid with Si. That's what that means, liquid plus Si. So this on our diagram with an element name equals some solid. And that's 19. Oh, both of these IOD because you are pulling out a number, IOD because you are going and tracing a graph. 20. A solder is a metallic, this is going to be IOD again because already those are numbers. A solder is a metallic material designed specifically to have a very low melting point. To make a solder out of an AU-Si alloy, what atomic percentages of AU and Si would be most appropriate? So we need it to have a very low melting point. So, let's see. The gold's melting point is 1100. Silicon is 1400. So that's not what we want. 100% Si and 100% AU. We do not want those because those are pretty high, I would say. So we can cross off F and J. Now, let's look at these. So, 80.5% Si. And then these lines, by the way, are the melting points. Pretty much of when they when they turn into liquids. So, 80.5% Si. I'm just going to trace the 80 line. That's still pretty high. Now let's try 19.5. Oh, look at that. That's the eutectic point. That's a very low melting point. So the answer is G. In comparison with the rest, that is the lowest by almost 1,000. Okay, 21 and 22. Just getting right on through this passage. 21. Based on the information in figure 1, surprise, we're going to figure 1 again. One could generalize that for the AuSi alloy compositions containing atomically less than 10%, the temperature at which the alloy becomes completely liquid decreases with. So, we're going to figure one. I don't really understand what that question is asking me yet, but I'm going to unpack these. So when it's less than 10% silicon, so that means I'm going to be looking just here. This is the section of the graph that I am looking at. So, what happens? This is IOD again, by the way, because we're pulling something out of that graph. We're pulling a trend. Okay. The temperature at which the alloy becomes completely liquid. That is just another word for melting. What does it do? So it decreases with, and we'll look. So for these temperatures, and I'm going to retrace this in orange, so I know that's hard to see now, but just follow along with my hands. What does this do? So the temperature decreases as what is happening to the SI percentage, and that is increasing that way as this is decreasing that way. So our answer is A, increasing SI percentage. Boop, boop. Okay, a liquid AuSi alloy, and we could cross off AU automatically, by the way, because it's not a line on graph. Nope, it's not here for us. Negative. And then these two, if you strategy it, are almost identical. Okay, 22. Let's do brown today. Everyone's favorite color. A liquid AuSi alloy of unknown composition is gradually cooled from an initial temperature of 1500 degrees. Solid particles begin forming at 1200. The particles must consist of which material? Also IOD. So we start at 1500 degrees. We're here. Okay, solid particles appear at 1200. Solids. What are they consisting of? And what must be the approximate alloy? Okay. So, we need it to actually hit 1500 on the graph, so that's about going to be here. And now the solid hits at 1200, so that means it's going to be liquid plus SI. Okay. And what do we think the composition is? So, they're not going to be AU because AU melts under 1200. And again, under 1200. But silicon's melting point is at 1400. That means it would be unmelted at 1200. You guys learned this, by the way, in quarter 1, and I told you it's the one thing that's science that's actually on the ACT. So actually on ACT and actually science. Okay, so the particles are SI and the atomic composition is 73, or the particles are SI and the atomic composition is 90. Let's see. 90 if we trace it up to here, and 70 if we trace it up to here. Well, when did this line hit there? That means that we're going to go to that 70. You trace the lines in your graph. Where did they meet? So the answer is H.